Now that we've talked about range and deviation as a way to measure spread of a data set, we go ahead and look at the idea that gets used in statistics, and we introduce it now in this class. It's called standard deviation. And you can read here, the standard deviation tells us the typical amount of deviation from the mean that we see in our data. So the idea is that we're going to use the deviations, the values we calculated previously, but what we do is we average those deviations. We take an average of how far on average each of the data points are. So it looks complex. This equation here looks complex here, or this formula here. This is the symbol for population standard deviation. It's called sigma. Again, we'll talk more about that, especially in statistics. But it's just the unique Greek letter we use to signify we're calculating the standard deviation. So it stands for the standard deviation. And so looking at those values here, X stands for the data values. This stands for the mean. And this is the number of data values. Let's look at an example and we can go back. So it looks complex, but again, looking at this, there are a series of steps to calculate the standard deviation. So looking at a set of values, something like this here, looking at a set of values like here, what's the standard deviation for these values? Meaning how far on average are each of these numbers from the average? So the first step you need to do is calculate the mean. And so we do that, add them up, divide by 5. So it turns out the mean is 5. And then what we do is we're calculating like a deviation. How far, we're calculating the difference, how far is each of these numbers from average. So notice we're taking the 4, 4, 5, 6, 6, 4, 4, 5, 6, 6, and subtracting from 5 because we're calculating how far they are from the average, which is 5 here, the mean, okay? And then what we do is after that, you square each of those deviations. So this is the series of steps you use to complete this. And then after you square them, you add them up. You sum them up and divide by how many data points there are, which are 5. And then at the end, you take the square root. Again, it's hard to explain the whole process. Not the process, but what the formula is. But this is the process. So this turns out to be 0.8. Square root of 0.8 is 0.89. And so that would be your standard deviation. Let's look at another example here. The mean of this data is 5. Again, we know this already from these are the two data sets we used previously. Find the deviations. We square those numbers and add and divide by 5 and you get 3.74. So you can see it's a larger standard deviation. This is the standard deviation. It's larger. 3.74 is larger than 0.89. And we can see that in this picture back here. These numbers are closer together, so they're going to have a smaller standard deviation. These numbers are farther from the middle or the average, so they have a bigger or larger standard deviation. So that's what you have there. Here's an example so you can take a look at that. You can see the different numbers. We have to first calculate the mean, and then you find the differences between each of those values and the mean. You square them, you add them up, and divide by how many data points there are, which are 4. Get that answer and square root that, and that turns out to be the standard deviation. Again, we're looking at this process here. This is the series of steps you use to get these answers here. So I'll pause there so you can look at that. You might want to pause the video to do that. And so with this small number here, that means on average most of these values, right, the data is close to the mean. It's pretty close, within about 2.75. So that's what we're measuring with standard deviation. And then the last thing here is you would want to be able to determine just from a graph which one has the largest standard deviation. And so you can see the largest is going to be set A, this one here. Because you see here's the mean is in the middle and the average is in the middle. That's a measure of center, the middle. And so you can see you have a lot more values that are farther from the mean. So this would have the largest standard deviation. This one here has more values close to the mean, And so group C would be the smallest set. And again, it has to do with how close they are to the middle, because the middle is our measure of center, or the mean in that case there. And then there's an answer to this question here that you can look at. What does this mean? That means a lot of people scored, the average is 72.4, but most people are around 11.7 points away from that. So most people scored like from 61 to 83. That's what that kind of number would mean. But we'll talk more about that, especially in statistics. But for now, you want to at least have a general idea of what standard deviation is, and for sure how to calculate it.